Hi guys, today our group will discuss the hydrogen as an alternative fuel for transportation in this video. This is the structure of the video. At first, I will give the definition of hydrogen. Then Mengyue and Hongyu will deeply talk about the possibility of the use of the hydrogen through comparing the hydrogen source and fossil fuel. Hongyu will also mention the developing direction and the financial benefits of the hydrogen. And last but not least, Mohsin will give the 3 applications of the hydrogen. I will also turn to the information in the end of the video. Okay, let's start. As more and more attention was drawn to environmental problems, hydrogen actually be thought of a future of fuel. Hydrogen has existed for a long time as an element in the earth. We could find it anywhere. However, pure hydrogen is scarce in the earth. It always exists as a form of the water by combining oxygen. How people get the pure hydrogen? In the simple explanation, we split molecules to get it. We always get the pure hydrogen from other things. So, how people could convert this element to clean fuels? Next shortcut will give you answer.
To do this requires an input of energy. You can use methane through a process called steam reforming, or a source of electricity through electrolysis. Once you have some hydrogen, you can either burn it directly or mix it with oxygen in a fuel cell, which is rather like a battery. The reaction in the fuel cell produces electricity and heat, and the only waste is water.
I'm Zhang Mengyue, and now let us compare fossil fuels and hydrogen energy. The first aspect is emissions compared to fossil fuels and hydrogen energy. At present, fossil fuels are the most important energy consumed in the world. According to World Energy Resources 2030 survey summary, on a global scale, the proportion of fossil fuels is 82% of the total primary energy supply. Due to the extensive use of fossil fuels, the environmental contamination caused by their emissions is becoming more and more prominent. Coal, diesel fuel, gas oil line, and some other fossil fuels can produce a huge number of pollutants in the combustion process. The International Energy Agency WEO 2016 special report on energy and air pollution shows that in countries with different income levels, fossil fuel combustion accounts for the majority of global air pollution, which producing 85% of air respirable particulate pollutants. This data shows that almost all sulfur dioxide, carbon monoxide, and nitrogen oxides are discharged into the atmosphere that causing inevitable damage to the environment. However, the emission of hydrogen energy as renewable energy is very clean. From the hydrogen combustion equation, it can be said that hydrogen after combusting only produces water vapor and releases a lot of heat. In addition, hydrogen energy is a good choice to replace fossil fuels in transportation, such as the use of hydrogen-powered vehicles. When hydrogen is combined with oxygen in fuel cells, it can not only generate electricity to provide power for the vehicle or drive the motor as a heat source, but can also achieve zero pollution emission. Nowadays, many countries advocate green hydrogen because it is the most sustainable and truly carbon-free energy. According to Charlotte, in the German rural region, green hydrogen could reduce carbon dioxide emissions by up to 25 million tons, so hydrogen power is a good choice. The second part is about efficiency. Hydrogen is an efficient energy type because it can deliver a lot of energy per pound of fuel compared with fossil fuels. According to the table from World Natural Association, it is obvious that the calorific value of gas oil line is 44.8 trillion per kilogram. That of coal is 32.5 trillion per kilogram. However, the calorific value of hydrogen is 140 trillion per kilogram, which is more than 3 times higher than both gas oil line and coal. Then from the value in the column of specific heat of different fuels, it can be seen that the heat capacity of hydrogen is 61,000, which is 3 times higher than that of gas oil line and coal. Therefore, the above data can show that the calorific value of hydrogen energy is very large and the energy density is very high. The wide specific heat means that it has a strong heat release capacity. Hence, hydrogen energy can produce energy in a more efficient way after combustion, which can also reduce waste.
Hi, my name is Hongyu. I will talk about another benefit of hydrogen. The third benefit of choosing hydrogen as alternative energy is that hydrogen is infinity. This means the combustion and production of hydrogen form a circle. Specifically, as Mengyue mentioned previously, hydrogen is burned to generate electrical energy or heat from chemical reactions, and then it will produce water. Then, as the United States Geological Survey states that about 71% of the Earth's surface is water covered, and the oceans hold about 96.5% of all Earth's water. The abundant water on the Earth and the water produced by combustion can be used to regenerate hydrogen from electrolysis, as Shu said. In this way, this process could cycle forever. Whereas for the use of fossil fuels, Raz indicated that the oil is only sufficient for the next 46.2 years from the end of 2010. Natural gas can only supply 58.6 years of global production from the end of 2010, and coal could only meet 188 years of global production. These statistics imply that the use of fossil fuels is limited, which is not a sustainable choice. After the comparison, it is clear that hydrogen can be the potential leading alternative transportation fuels due to its abundance of water and the cycle of production of hydrogen.
Hi, I'm Mohsin, and I'll be talking about 3 applications of hydrogen. Next slide. Hydrogen fuel cells are a type of electrochemical cell that produce electricity by converting the energy produced from chemical reactions into electricity. In this case, hydrogen fuel cells conduct reactions involving hydrogen and oxygen atoms that generate electricity, heat, and water. A transfer of electrons between the hydrogen and oxygen atoms, known as redox reactions, occur, as shown in the diagram, which provides energy that is converted into electrical energy. The size of the fuel cell will determine what it can power, as large fuel cells are able to supply electricity to power grids, emergency power in buildings, as well as provide electricity in small regions where electrical power grids don't have access. Next slide. Transportation. Hydrogen can also be utilized as a fuel for transportation. Whilst the method of electricity generation is still a hydrogen fuel cell, it can provide hydrogen fuel cell powered vehicles with electricity. Same mechanism as an electric car that uses a battery charged by electricity but without the use of the battery. Hydrogen can also be used in internal combustion engines, but it will result in the emission of nitrogen oxides, a type of greenhouse gas, and will be less efficient than a fuel cell powered engine. There are 0 emissions in a fuel cell vehicle since only water and heat are produced, and are much more efficient at traveling long distances. Today, a fuel cell powered vehicle can travel about 100 kilometers with 1 kilogram of hydrogen, whereas internal combustion vehicles only get 40 kilometers on around 4 liters of petrol. Next slide. In spaceflight, liquid hydrogen is an extremely powerful and light rocket propellant with a great burning intensity that in combination with liquid oxygen provides the highest efficiency than any other rocket propellant in relation to propellant consumption. NASA has been utilizing it since the Apollo program. Its low molecular weight is beneficial in storing large amounts, but both oxygen and hydrogen are cryogenic, meaning that they can only be liquefied at extremely low temperatures, around negative 250 degrees Celsius. So its usage, storage, and acquisition won't be probable for personal vehicles, but rather for vehicles in industries where corporations are able to spend large amounts, such as in the aviation and spaceflight industry.
For the future of developing hydrogen, the development of myths and job opportunities are the economic reasons why it is worth developing hydrogen energy in the future. International energy agencies claim that with the global energy market influx, the multiple applications of hydrogen, like Mohsin mentioned, are attracting a wide range of governments and companies to carry out further studies. This implies that the investment in hydrogen could foster new technological and industrial development in economics all over the world and create occupations. For instance, the government's National Hydrogen Strategy in 2019 reports that the Australian hydrogen industry would add about 11 billion a year in additional GDP by 2050, and will also create about 7,600 employment opportunities. Thus, technological innovations have the power to develop renewable energy industries considerably. About the development direction, according to Gonzalez Maciaca, hydrogen can be produced from fossil fuels and renewable energies, such as natural gas and coal, and solar and wind energies. If we want to achieve true net zero emission, we need to use renewable energies as a source. Regarding its cost, here is a bar chart of the hydrogen production costs by different production methods in 2018. From this chart, we could know that the cost of producing hydrogen with clean energy is the most expensive one among these three sources, which is $3 to $7.5 per kilogram. Hence, it is recommended to put more effort to reduce the cost of hydrogen production by renewable energy in the future.
In conclusion, hydrogen energy is a suitable alternative transportation fuel to replace the fossil fuels to a large extent. We've considered the three benefits of the hydrogen. There are no emission pollution, high efficiency of production, and the infinite hydrogen source. After that, we talk about the three applications of the hydrogen energy, which are hydrogen fuel cells for electricity, transportation, and the spacecraft. From our final analysis, it is recommended to think about how to achieve the reduction of the cost of hydrogen production by renewable energies in the future, so as to make hydrogen energy widely adopted and sustainable development.
This is our reference list. And this is our group member attributions. Thanks for listening.